Hi, I'm Christian. I'm a PhD student at Goldsmiths in London. I'm part of the Center for Intelligent Games and Game Intelligence, and I'm really interested in one tough question. How can we engineer AI systems capable of supporting and challenging us as people in an open-ended way? In other words, how can we get AI systems to support us in all sorts of situations, not only those that we can foresee during development? In the past few years, video games have proven really valuable for advancing AI towards human-level intelligence. But sometimes games do not have to serve exclusively as stepping stone. My research contributes to this overall hard challenge, but it also has the potential to impact and advance both games industry and research. And here is how. One of the things that makes games truly exciting and engaging are the characters that populate the game worlds. Supportive characters draw us into the game and show us how things work, and enemies provide the crucial element of challenge in many games. Traditionally, the AI behind game characters, such as these, is meticulously handcrafted. This manual engineering means that game AI designers have to anticipate what could potentially happen after the game has shipped and when you play it on your phone or telly. But as game worlds are getting bigger and bigger, and new technologies enable us to create new content on the fly, this becomes a problem. The AI can simply break, ruin your experience by getting into your way, or it might simply not react when you put a pot on their head, thus destroying the illusion. This is where my research kicks in. We have identified a unifying principle of what it means to support or challenge a person, to either increase or to decrease their future options. Consider collecting resources in a strategy game, enabling you to build more facilities and produce more units, thus gaining more options and degrees of freedom overall. Or think about collecting a more powerful weapon in a shooter, thus not only increasing the alternative weapons to choose from, but also the power to affect your enemies and surroundings. We measure these options by means of information theory and a quantity called empowerment. Our algorithm, coupled empowerment maximization, induces a paradigm shift in game AI. Instead of hand-tailoring what to do in which situation, our AI generates their own goals. It is intrinsically motivated. As a consequence, the behavior that we get is emergent. Depending on the character's abilities and features of their environment, we get supportive behavior such as following the player without blocking it and defending it against enemies. We can also use this approach to yield adversarial behavior. What we get is not the stereotypical enemies that we see in most games. Instead, our AI will adapt to the current situation and make use of everything it affords. Equipped with the ability to push, our characters will push the player into a stream of lava. Given the ability to fly, they will instead escape over the lava where the player can't reach them. And equipped with the ability to strike from a distance, they will do so in order to not risk their own skin. Crucially, our algorithm is not limited to one particular game. It can potentially be reused across different games with very few modifications. With this new technology, creative industry practitioners could stop worrying about re-implementing behaviors manually over and over again. Instead, they can save time and money and focus on their characters' abilities and the world around them to trigger new fascinating interactions that might surprise themselves, but most importantly, they'd yield a more engaging experience for the players. At this point, however, this is really expensive to calculate. As a matter of fact, its complexity grows exponentially. And that's why I'm teaming up with Microsoft Research Cambridge to scale it up using deep neural networks and reinforcement learning. Many thanks to this great bunch of people for supporting my research, and many thanks to you for watching. If you want to hear more about this research, please get in touch, either at the conference, via email, or on Twitter.